null hypothesis. It means it's unlikely for us to observe our data if we hold that initial belief.
How small would that be?
Yeah, let me explain it. So it is, let me just write this. It says, it is unlikely for us to observe our data if the null hypothesis or initial belief is true. That's what it means when our p-value is small. And let me just write what the other side means. On the other hand, if the p-value is large, then it is quite possible for us to observe our data from random chance alone. Okay. So we would not reject. We would not reject our initial belief. So in that situation, if I go to another island and I take a random sample of 100 people and I get 55 females and 45 males, it's possible for me to get that kind of sample just from the random nature of sampling, even if the island truly is 50% male and 50% female. Yes. But it doesn't prove that the island is 50% male and 50% female. A random sample where I get 55 females and 45 males doesn't prove that the island is 50-50. It just doesn't refute that initial belief. So we just say we don't reject the null. We never say we prove or we accept the null. We just say we don't reject it. Next question.
If it is large, would it be equal to something? Like, would there ever be a point where it's equal to p-value equal to the actual?
Like your hypothesis is correct. Like, yeah.
Exactly. Like, would that still be considered large, or would
So-
there ever be a point where it's equal? Like, if your hypothesis is true and it's exactly that number, you predict?
It's possible, okay? So maybe I go in with the initial belief that the island is 50% male, 50% female. I take a random sample of 100 people, and I get 50 males and 50 females. Does that prove that the entire island is 50% male, 50% female? No, it doesn't. It just means that based on this data, based on this sample, I have no reason to reject that belief. I have no reason to think that the island isn't 50% male and 50% female. But a random sample of 100 people doesn't prove that the island is 50% male and 50% female.
So it would still be on the correct side where the p-value is large.
So it falls under this category that the p-value is large. Okay, it's quite possible for us to observe our data from random chance alone. Okay, and we just say we would not reject our initial belief. We would not reject the null hypothesis. Okay, but maybe I'll write do not say H0 is correct or H0 is true. because we don't know that. What's the only way for us to determine if the island truly is 50% male and 50% female? Yeah.
Get all the people and see how much.
We would have to look at the entire population. The only way for us to know if P, the population proportion, is 50%, is to look at the entire population. But we're going to assume that the entire population is too big for us to directly observe.
This goes along with the other question. And so if it's less than, say, like 5%, would that still be considered correct?
We're talking about a p-value here.
Right. So if that your p-value is like 49 and it's actually.
No. The p-value is not the p-value is not the percentage of your sample.
Okay.
The p-value is the probability.
Okay.
Okay? So when is the p-value small and when is the p-value large? That was the question that we had. Okay? Well, the truth is we have to decide when the p-value is large and when the p-value is small. A good rule of thumb is that, listen up. A good rule of thumb is that if the p-value is less than 5%, it's considered small. And if it's greater than 5%, it's considered large. But that is not the end-all be-all rule. And there is some wiggle room, okay? But that's our general rule of thumb. We have something called a significance level called alpha. And generally, we pick alpha to be equal to 5%, 0.05. But alpha can be 10%, alpha can be 1%, or anything in between. But generally we say alpha is 5%, and if the p-value is less than alpha,